Struggling with how to transform data in Terraform? This is the video for you. What's up, everybody? It's Ned Bellavance, nedinthecloud.com. Welcome to another Terraform Tuesday. Today's topic is data transformation. This is another video in my series to help you prepare for the Terraform Authoring and Operations Professional exam, also known as the Tau Pro exam, because it's easier to say. In this particular episode, we are going to cover how to transform data inside of Terraform using a combination of syntax and functions. So let's dive right in. First, a little context. Why do you care about this? Well, the reason is that information that you're passed as inputs or garnered from data sources may take on a ton of different formats that you may or may not have any control over. As a Terraform operator, it's your job to take the data as it's presented, make sure that it's valid, and then transform it as needed before passing it along for resource creation. In this video, we're going to dig into the process of data transformation using common input formats like YAML, JSON, and CSV, and how to use expressions, functions, and ternary operators to transform that data into something usable. The first thing to keep in mind is that Terraform is declarative in nature, and so are its constructs. For expressions transform existing values, but they don't do so in a procedural way. If you're used to bash scripting or PowerShelling with do, while, and for loops, using the for expression in Terraform is going to take some getting used to. I find the best way to deal with the declarative expression is to think of it more as a query. If you were in a procedural context, you might write something like, for each subnet in subnets, check to see if the subnet is public, and then run some command to set the Azure Virtual Subnet config to the NAT gateway. That's a very procedural approach. That's not what you would do with Terraform. With Terraform, instead, you need to query for a list of subnets that meet some condition. Maybe that's a condition where they're private, and then use that list to create a NAT gateway association. So a similar version of the Terraform code is first we could create a local value called private subnets and use a for expression to look through the existing subnets that are coming to us and only include in our new map of private subnets where is public is not equal to true. Then I can take this new map of private subnets and iterate over them using a for each construct to create each subnet and each subnet NAT gateway association. So that's the general idea. The contents of my var.subnet could be something as simple as the key being the name of the subnet, and then the value of that key would be a map of address prefixes and whether public is set to true or false. The for expression is not actually looping through the construct. It is querying it and doing a data transformation on each record returned. The if statement at the end of the for expression returns two records, and I'm then getting a new data structure composed of the key and value of the two records. You can think of it as like a mini ETL. If you've done work with JQ and JSON data, some of this will feel very familiar. With that in mind, let's review some syntax and functions you're going to want to know from Terraform's implementation of HCL. For syntax, you're going to want to know how to use for expressions and conditional expressions. Now, I've done a whole video on for expressions, which I'll link up in the doobly-doo. But the quick version is this. For expressions transform one complex data structure to another. The input can be any collection or structural data type. That includes lists, sets, maps, tuples, objects. The output for a for expression can be either a tuple or an object. If you're a little fuzzy on data structures, I have a Terraform Basics video that covers those. For this video, I'm going to assume that you already understand them. A for expression is enclosed with the symbols that signify which data structure you want as output, square brackets for a tuple and braces for an object. Inside the for expression, you need a local variable to refer to the current item that you're examining. If the input data is a list, a tuple, or a set, you only need one local variable. If it's a map or an object, you need two, one for the key and one for the value. So our for expression, curly brace for k, v in var.subnets, is iterating over an object, var.subnets. And so we have local variables k and v for the key and value, respectively. You can use whatever name you want for the local variables. I recommend keeping it short and simple, but clear. If you find that you need to nest for expressions, the local variables for the nested expression have to be different than the containing expression. And we'll touch on nesting later. The output for a for expression is composed after the colon. If you're constructing a tuple, you simply need a value. That's what's in tuples. If you're constructing an object, you'll need a unique key followed by an assignment syntax of equals and greater than, which looks like an arrow. After that, it should be the value you're assigning to the key. In our example, we're assigning the existing value exactly, but only if the property is public is not true. The if statement comes after the value assignment expression. There's one more syntax item that is maybe going to be on the exam, and I think it's very useful. Let's say you have multiple values you want to assign to a single key. Let's say we had a structure like this for our firewall rules. So we have the name of each firewall rule equal to a map that contains the port, protocol, direction, and permission. What if I want to break this up into two lists? I want one for inbound and one for outbound. If that's what you need, then this syntax will do exactly that. We have a fairly typical for expression here where we're iterating over or querying our firewall rules. The interesting thing is at the end, we're looking at the rule.direction property and then assigning that the names that correspond to that rule.direction. Direction can be inbound or outbound. And then we have this ... at the end, which is an expansion or grouping operation. Terraform interprets that to mean take all of the rules that have inbound and assign the inbound key a list of the names associated with inbound. So what I'll get back is a map with two entries in it, inbound and outbound, and the value for each of these is going to be a list of the names of the rules that have inbound or outbound respectively. That's pretty cool. Now let's move on to conditional syntax, which is much simpler. It uses the ternary operator, and the general form is condition, question mark, value if true, colon, value if false. The conditional expression must evaluate to true or false. You can also chain ternary statements like condition, question mark, value if true, colon, condition, question mark, value if true, colon, value if false. You can repeat that as many times as you need to, but I don't recommend chaining too many values, otherwise the code becomes unreadable. Now let's move on to functions. Terraform has a ton of useful functions for transforming data. I'm just going to hit the highlights here, but I encourage you to play around with all of the functions listed in the collection, string, and type conversion categories. But here's the highlights. From string, join lets you create a single string from all the elements in a specified list using the selected separator. So if you have a list and you need to turn it into a string, join's your friend. The inverse of that is split, which is basically taking a string and splitting it into a list using the selected separator. So if you're getting back a string that you know is a list from a data source or as input, you can split it into its component parts as long as you know what the separator is. The last function I want to highlight from the string category is regex. This returns a match to regular expressions. This can be combined with the can function to return a true or false result. So yes, you can do regex in Terraform. Now let's move on to collections. The coalesce function returns the first argument that isn't empty. It can also be used with lists if you add expansion dots at the end. Compact removes any null or empty values from a list. So if you're processing data and you're going to get back a list that may have some empty values, you can use compact to get rid of them before you use it in some other context. Concat lets you combine multiple lists into a single list. Distinct will remove any duplicate values from that list. Flatten takes nested lists and flattens the values into a single level list. So if you have a list of lists and you just want one big flat list, flatten will get you that. And then if you have duplicates in there that you need to remove, you can use distinct. You can chain these functions together to do the data transformation that you need. The last one I want to highlight is lookup, which allows you to find the value of a given key in a map. Yes, you can do this with just normal Terraform syntax, but what's interesting is that lookup provides an optional third argument to return a default value if that key isn't found. And that's something that the normal syntax for referencing something from a map doesn't do. So if you're not sure if that key is going to exist and you have a default value you want to use, the lookup function is your friend. Now let's talk about encoding. There are 3 functions that are super useful when it comes to encoding, or really decoding in this case. We have YAML decode, JSON decode, and CSV decode. I think you can figure out what all 3 of them do, but essentially each one takes data in the source format of YAML, JSON, or CSV and turns it into an HCL data structure that Terraform can manipulate. If you're going to be getting input in YAML or JSON or CSV from somewhere else, you can convert that into an HCL data structure. Very useful. The last group I want to mention is type conversion, and specifically 2 functions out of there. First is can. Can returns false if the nested expression returns an error, and it returns true otherwise. This is extremely useful when you're creating validation or conditional expressions. Not every function is able to return a true or false, but if you want to check to see if it returns an error, then the can function is what will help you do that. The other function is called try, and try takes a list of arguments and returns the first one that doesn't result in an error. You have several arguments in there, and the first one of those arguments that doesn't result in an error is what try will return. This is very useful for when you're working with complex data structures where the structure is not well defined or the values might be absent. Try can help you out with that. Like I said, this isn't an exhaustive list. You will have access to the Terraform documentation during the exam, but if you don't even know where to look, it's not really going to help you. Focus on the purpose behind the function. Don't worry so much about its exact syntax because you can always look that up during the exam. It's more important to be aware that the syntax exists at all. The last thing I want to mention is the Terraform Console. The console is going to be your best friend when evaluating expressions. Terraform Console has access to your current state data, the input variable values, and the local values in your config. You can rapidly iterate on an expression until it returns the desired result, and then paste that expression back into the config. Make sure to get comfortable with the Terraform Console. Okay, now that we have all of that information under our belts, let's go into some challenges that I've constructed that you can work on your own. Over in VS Code, I have my Terraform Tuesdays repository open, and I have a folder that's for the Tau Pro 2 video. And I have 3 different challenges inside of here. One for CSV, one for JSON, and one for YAML. I'm going to walk through the CSV example here with you, and then leave the rest as an exercise for you. In the CSV directory, I have 2 CSV files. The first is simply server data, and the other is made up of more complicated firewall rules. To know more about the challenges, I have a README in here that describes what the challenges are for this particular exercise. Our first challenge is to import the content of the data CSV file into a local value. And then our second challenge is to create an output that's a map of server names to their type. So let's go into the main.tf and start working on that. Inside the main.tf, I already have a locals here that contains the transformation that you'll need to do. And it uses two functions. The first is file to get the contents of the data.csv as a string. And then we use the CSV decode to take that CSV data and turn it into something that Terraform can use. And that's housed in the CSV_data local value. The second challenge was to create an output that has the server data presented as the name of the server equals the key. Before we try to create the output that maps server names to the type, I'm going to pull up the terminal and start up Terraform Console from this directory. That will read in the locals that are defined inside this configuration, and I can view what the current structure is of local.csv data. Now I can create a for expression that creates the output of the name of the server equals the type of the server. The data type I want out of my for expression is an object. I'll start my for expression with the curly braces to get that back. Now the object we're iterating over is local.csv data, which is a list. So I'm only going to need a single variable, I'll call server, to hold that information so I can query it. After the local.csv data, I'll put the colon, and then the assignment is going to be server.name, that will be the key, and we're going to assign it the value server.type. I'll close the curly brace and hit enter, and boom, that's exactly what we want. So what we can do is take this information and copy it, and create a new value in our configuration, and we'll set the value to, well, it looks like GitHub Copilot is trying to help me, but I want to do this myself, so I'll paste the expression that I just ran in the console as the value for this output. Okay, so that's the second challenge done. What's the third challenge in here? Third challenge is to create security groups, and we're going to be using the contents of the firewall rules CSV file. We're going to need to create a security group for each system listed in the CSV file, and then create security group rules for each of the security groups using ingress and egress resource types. This is going to be challenging. So first, let's take a look at what's in the CSV data. Each rule in the CSV data does reference which system it's for and which direction the rule is pointing. Okay, so what do we need to create the AWS resources? If we look in the main.tf, I've already included the necessary resource blocks. We're going to need an AWS security group for each system, and then ingress and egress rules. What information do I need out of the CSV data? Well, I need a list of system names for the security groups. Then I need a list of firewall rules that are either inbound and another list for outbound. We're going to use the for each meta argument to create the groups and the rules, which needs either a set of strings or an object. For the groups, I can use a set of strings with the system names. For the rules, I'll need to create an object from the list of rules. It looks like the rule IDs in my CSV data are unique, so that can be the key in that object. Okay, first we'll get the system names, which I'll do by creating a local value called systems and using a for expression to get a list of just the system property from every rule. Then I can nest that in a distinct function to return the unique values only. Once again, I'll pull up the terminal and first try to write the for expression inside the terminal to make sure that it returns back the correct set of values that I'm looking for. It's a relatively straightforward for expression, so I won't describe the whole thing, but it does in fact return all the systems, but they're repeated. So I can add the distinct function when I create the local value to get this down to just the unique values inside of this list. Once I have that local value, I can now create the security group. I'll start with the for each meta argument and set that equal to toSet to turn what is a tuple into a set of local.systems. Then the other two arguments I need to specify are name prefix, which I'll set to each .key, so it will start with the name of the system, and then VPC ID for where to associate these security groups, which VPC to associate with them. Okay, awesome. We've covered the first thing, which is creating those security groups. Now we need to create our ingress and egress rules. First, let's try to create our ingress rules object. And before I do that, I need to convert the list of rules into an object. And so I'll do that using the rule ID field as the key for the object and the rule itself as the value. Then I'll use an if expression to filter the results where the rule direction is inbound. Once I've verified that my expression is correct down in the console, I'll add it as the value for the for each meta argument for my ingress rules. I still have to populate the rest of the arguments, and here's where things can get a little hairy. Security group ID we can find by referencing the security group by system name. Next up is the CIDR IPv4 argument, which corresponds to the source IP. Next up is the from port. This is the starting port, and here's where we run into some trouble. If we look at the entries in our CSV file, some port range entries have a single port, and others have a range. This is absolutely the kind of crap that you'll get from other systems, and you just have to deal with it. The from port portion is easy. We can simply split on the dash and take the first element. Even if there's no dash, it will just return the first element. What about the to port? Now we have to deal with two different scenarios. If there's a range, we need to use the value that's after the dash. If it's not a range, we can just use the from value. There's a few different ways to handle this, but the easiest is probably using the try function that we talked about earlier. Try will return the first successful argument in the list you provide. So the first argument will split the port range string and return the second element. If there's no second element, then that expression will throw an error and try will move on to the next expression. For the second expression, we'll split the port range string and return the first element. And boom, we've dealt with the weirdness in our data. Let's see the try function in action at the console using some example data. At the console, I'll add the try function, and then I'll have our first argument, which is to split on the dash and return the second element. I'll try it where it's going to throw an error, where there is no second element because we're only passing the value 80. That's going to be both the from and to value for the port. After the first argument, I'll add a second argument that's basically the same. We're going to split using the dash on the value 80, but this time return back the first element. When I run this, I'll get back 80 because the first argument is going to error, so try will attempt the second argument, that one's successful, and that's what it will return back. Next, I'm going to run the same thing, only this time I'm going to provide a range, and it's going to be 80-443. So it's the same exact expression as before, but with a different value. Once I complete typing this in and hit enter, now I get back 443 because the first argument was successful. We've now covered both scenarios that we're dealing with in our data. I'll copy and paste that expression from the console, and all I need to do now is replace that dummy data with the each.value port range reference to get the actual port range of the current rule that we're working with. The last argument is the IP protocol, and that's simply a reference to the protocol that's in the rule. And that will do it for the ingress rules. You can rinse and repeat the same thing for egress rules, just changing the filter on rule direction from inbound to outbound. At this point, you should be able to run a successful Terraform plan if you have your AWS credentials loaded and see that it will create the correct ingress and egress rules along with the security groups. Congratulations, you've finished the first exercise. Looking in the directory, there are two more exercises that are a little less involved, but dealing with different data types. We have one for JSON and one for YAML, and once again, the challenges are included in the README doc for each one. Hopefully, by going through these exercises a few times, you can get a feeling for how data transformation works in Terraform, and this will help you prepare more for the Tau Pro exam. In fact, I had someone reach out about this exact topic, and I passed them the examples, at least as they were at the time, and he said they were definitely helpful in getting him prepared or feeling a little more ready for taking the exam. Please let me know what you think of the exercises and what topic within Tau Pro you want me to cover next. You can do that down in the comments. As always, thank you so much for subscribing. I hope you found this video useful. If you did, maybe you can like and share it. Until next time, keep calm and Terraform on.